In this lesson, we will be solving equations, but we will need to know things about fractions, how to multiply and divide. So let's just take a minute and review some things about fractions. Now you know, in order to multiply fractions, if I want to go 2/3 multiplied by 1/4, you can just multiply straight across. 2 times 1 is 2, 3 times 4 is 12, and then you could reduce. 2 goes into 12 6 times. That's one way. Or you could have gone 2/3 times 1/4 and reduced along the way and said 2 goes into 4 2 times, and then we'd also have 1/6. So multiplying is pretty easy. You can either, again, multiply straight across, or what I like, reduce along the way. But what about division? How do we divide fractions? Well, you take the first fraction as is, but then you multiply by the reciprocal of the second fraction. You multiply by the reciprocal of what you are dividing by. So now I'm going to multiply straight across. 2 times 3 is 6, 5 times 1 is 5, and we can leave that as an improper fraction. We don't need to reduce it. On the last lesson, we looked at the addition property of equality. This lesson, we're going to be looking at the multiplication property of equality. And what it says is if you have two things equal to each other, if you multiply both sides of the equation by the exact same quantity, then it will not change the solution. So let's see. If I have 2 times x equals 14, and I want to take that equation and I want to multiply both sides by 1/2. My multiplication property of equality says as long as I multiply both sides of the equation by the same thing, it keeps it equal. So I've multiplied both sides by 1/2, but what happens? Well, this is like 2 over 1. 2 goes into 2 one time, so I'm left with just 1x, and then I can reduce here as well, and I get x is equal to 7. And of course, we could have just looked at that and said, sure, 2 times 7 is 14. But again, you need to look at the algebra. Right, this time we have 1/4 times x. Well, what if I multiply both sides by 4 over 1? Can I do that? Yes, I can, because that's what this multiplication property of equality states. As long as you do the same thing to one side of the equal sign as you do to the other, the equality is maintained. So what happens here? Those divide and you just get 1x. Here that's over 1, so 5 times 4 is 20, or 20 over 1, and that's the solution to that equation. 1/4 times 20 does equal to 5, right? 4 goes into 20 5 times. So this lesson you're going to be seeing lots of fractions. So let's look at the first example. We're going to solve these equations. We want to get x by itself. So x is being multiplied by 2/7. Well, I can multiply by the reciprocal because, remember, if I do 1/3 times 3 over 1, I'm going to get 1. If I do 2/5 times 5 over 2, I'm going to get 1. So a fraction multiplied by its reciprocal, you get 1. So if I multiply the left side by 7 over 2, I'm going to multiply the right side by 7 over 2. And again, those all reduce, and you get x. And here I could multiply across, but those numbers are going to get a little bit big, where I could just reduce. 2 goes into 8 4 times, and then multiply 4 times 7 is 28. Another way of saying this is that you have 2/7 multiplied times x, so you can divide both sides by 2/7, but dividing by 2/7 is the same as multiplying by 7 over 2. And in this case, that's a little bit easier. Let's look at number 2. Here's x. Well, it's being multiplied by 40. Inverse operation of multiplication is division. So I'm going to divide both sides of that equation by 40. Well, 40 divided by 40 is 1, so that leaves me 1x. Now I have a fraction, 4 over 40. Can I reduce that fraction? Yes, you can. 1/10. So look at number 1, look at number 2. Could I have written number 1 like this? Okay, so here's number 1. Could I have divided both sides by 2/7? Well, yeah, but then that's just yuck. Don't want to really do that. But just to tell you, I did do that over here because, again, dividing by 2/7 is the same as multiplying by 7 over 2. Let's look at number 3. Now, what's happening to x? It's being divided by 8. Well, the inverse operation of division is multiplication. So I'm going to multiply both sides by 8. Why am I going to do that? Well, because those 8's are going to reduce to 1, and I'm left with 1x. That's over 1, so I just have negative 16. Isn't that easy? So what you want to do is you want to look at your x and saying, what is being done to my x, and how do I undo that? Speaking of which, let's look at this x. It's being multiplied by negative 240. So I need to divide by negative 240 on both sides. That reduces, remember, a negative divided by a negative is going to leave me a positive 1x. But ooh, can I reduce that? Well, I know a negative over a negative becomes positive. If I divide them by 10, the zeros go away, right? So I have 21 over 24. Can I reduce that some more? I think so. I think they're both divisible by 3, aren't they? 3 goes into 21 7 times, and 3 goes into 24 8 times. So remember, what I'm doing here is I'm dividing both of these by a common factor of 3. And that's how I'm getting 7/8. So yeah, it's a lot of fractions, but they're really not that bad. Okay, now look at number 5. This x is again being divided by a number, just like on number 3, x was being divided by 8. What did I do on number 3? If I divided by 8, then to undo that, I multiplied by 8. So this x is being divided by 3, so I'm going to multiply by 3, or 3 over 1. So those divide to 1. But here I can't reduce, not quite as pretty as number 3, but I can multiply and get negative 6/7. Again, if I'm going too fast, pause that video, rewind, take it a little bit slower. Alright, let's look at number 6. Again, look at x and ask yourself, what is happening? X is being multiplied by negative 5/4. Well, let's go back up to this first example. Let me just erase some of this so you can kind of see it. Remember, x was being multiplied by 2/7, and I undid that by multiplying both sides by that reciprocal. I'm going to do the same thing on number 6. It's being multiplied by negative 5/4, so I'm going to multiply by, and you just need to put the negative somewhere because I need positive 1x. So I'm going to multiply both sides by negative 4/5. So let's look at that right hand side. Those cancel out. Negative times negative becomes a positive. So I get that 1x, because that all divides in there one time. And over here, I just need to multiply across. I'm going to get negative 8 over 15. So look at those first 6 examples. Are you catching on? It's about to get a little bit harder. And you go, oh, but number 7 looks pretty easy. It does. Okay. If you remember from the first lesson, we need to get our x's on one side and constants on the other side. So the only x I have is right here. So what do I need to do first? Well, actually you do the opposite of your order of operations because you're undoing. So the first thing I need to get rid of is I need to undo this plus 1. So let me just rewrite this so I have a little bit more room. So how can I undo adding 1? I subtract 1. We did that in the first lesson. Now look at what's happening to x. X is being multiplied by -5. What undoes multiplication? Division. So I get 1x equals -2/5. Not to confuse you, but I could have looked at this problem like this. 2 equals -5x. I could have multiplied both sides by that reciprocal and gotten exactly the same thing. Just think about that. So let's look at this next one. So x is being multiplied by 3/4, but also has that adding 2. So I need to work backwards. I'm just going to move this over here so I have a little bit more room. Alright, so I need to undo the adding first. So I'm going to subtract 2 from both sides. That goes away. And then that's -6. Alright, now what's being done with x? It's being multiplied by 3/4. So yes, I could divide by 3/4, but I don't want to write it like that. Dividing by 3/4 is the same as multiplying by the reciprocal. And I think that is a lot easier because then I can see how all of that cancels out or divides out to 1. Over here, I could just multiply, but 3 goes into 6 2 times. Don't leave that negative out. So I have -2 times 4 is 8. And what do I have on the bottom? Just 1. So you could write it as 8 over 1. I'm not going to take off, but you should know that that's just 8. Ooh, now I've got more than one fraction. I could add all those fractions, but man, I would rather not. So I'm going to show you some math magic. Right? Let's just kind of write this where I have a little bit more room. You might want to kind of space it out. And I want you to look at the denominators. And I want you to find a least common denominator. Remember that? What is the biggest number? What's the smallest number that 4 and 5 divide into? And if you're not sure, at the very least, you could just multiply those numbers together. That would give you a common denominator. So in this case, they're the same, 20. So what can you do? You can multiply every term by 20. Every term by 20. Every term by 20. But you said, ooh, but I don't want to multiply that 3 times 20. I'm going to get a big O number. Yeah, but that equation, I have to keep everything equal, so I have to multiply everything by the same number. Why would I want to do that? Well, let's see. 4 goes into 20 5 times, and I just have 1s in the denominator. So that gives me 5x plus 60, again over 1, equals 5 goes into 20 4 times, and I have 4x. Now here's my question. Would you rather work this problem with fractions or this problem without fractions? I'm voting for the second option. So if I can get rid of those fractions, I'm going to do that. All right, so I needed to get x's on one side, so I am going to subtract 5x from both sides. Okay, that's 0. I'm going to bring down my positive 60. And yes, that's -1x. There is like a -1 there. I have to get positive 1x. So x is being multiplied by -1, so you can divide by -1. And so my answer is -60. So let's just review what we did. In step 1, we found the LCD. Step 2, we multiply every term by the LCD. Why? To get rid of all the fractions. Okay, that's why I'm doing it this way. You don't have to, but that's what I'm going to do. All right, so I have all these fractions. What's the common denominator? Well, I could use 18. 3 times 6 is 18, but that's not the least common denominator. There is a smaller number. In this case, the least common denominator is 6. All right, so again, I'm going to write this problem where I have a little bit more room to do my multiplication. So I'm going to multiply this times 6 over 1. I'm going to multiply this times 6 over 1, this times 6 over 1, and that times 6 over 1. And remember what I'm going to do to get rid of my fractions. So if I've chosen the right LCD, this is going to work. Meaning 3 goes into 6 2 times, and there's nothing left in the denominator. Now I'm getting kind of sloppy, so help me not lose anything. So that's 2x. That's going to be just minus 1. 3 goes into 6 2 times, but I've got to multiply all that together. So I got 2 times 5 is 10 times that x. Now what's in my denominators? That's just 1. Because 6 goes into 6 one time, plus 5. So again, I think this is easier than that. Now I'm going to get my x's together, and I'm going to choose taking them to the left. Actually, I guess I'm putting them on the right. So I'm going to bring down that negative 1, and I have 8x plus 5. Now I'm going to subtract 5 from both sides. And I get negative 6 equals 8x. So we've done a lot. We got rid of the fractions. I've got x's on one side, constants on the other, but now I have a coefficient of x, 8. So I can divide by 8 or multiply by 1/8. In this case, either one is easy. So I'm going to just divide by 8, and I'm going to get 1x, and then I have a fraction. It's going to be negative. Let's reduce it, and it would be negative 3/4. Those are a lot of problems. Keep in mind, if you have something like 2x equals to 3, it is very easy just to divide by 2. However, you could also think about multiplying by 1/2 on both sides, and you're going to get the same answer. So if you have a coefficient of x, you can either divide by a whole number or multiply by the reciprocal of a fraction.